Okay, today we're doing Eureka Math Module 5, Lesson 6, and today is the day after Earth Day, April 23rd, 2019. And today we're really going to focus on finding the total volume, all of the volume, of different figures that are kind of made up of more than one rectangular prism. Okay, so imagine what that might look like. Cool. Let's talk about the problem of the day. Okay, partner A built it in green. You can see it's 3 by 2 by 2. Yes? 3 centimeters by 2 centimeters by 2 centimeters. Let's label it. 3, he made it, the height is 3 centimeters. He made the width 2 centimeters and the length 2 centimeters. What is the volume of partner A's structure? 2 times 2 times 3, which is? 12 cubic centimeters. Good. Now Sawyer, partner 2, made a black one that was 2 centimeters by 2 centimeters by 2 centimeters. What's the volume of partner B's structure?
8 cubic centimeters.
Good. Now what happens if I take these structures and combine them like this? Do I have a new rectangular prism?
Yeah.
What's the volume? 20 cubic centimeters. How do you know? Talk at your table groups. What was the volume of prism A again?
12 cubic centimeters.
Okay. What was the volume of prism B again?
8 cubic centimeters.
Oh. Okay. So what's the total volume of this figure?
20 cubic centimeters.
Okay. What's the volume of this second figure?
20 cubic centimeters.
How do you know? Well, what was the volume of this bottom part, prism A?
12 cubic centimeters.
What was the volume of the top part?
8 cubic centimeters.
So what's the total volume of the whole figure I just built?
20 cubic centimeters.
What about this one here? Still 20 cubic centimeters, because you can see it's still made up of prism A, which is 12 cubic centimeters, and prism B, which was 8 cubic centimeters. So sometimes you might have a figure like this. Is this whole thing one rectangular prism?
No.
Is this whole figure right here one rectangular prism? No. But could I break it into more than one part?
Yeah.
And when I break it into two parts, is each part one rectangular prism? So I can find the total volume of a combined figure like this, even if it's not a rectangular prism, by breaking it up into different parts and finding the volume of each part. Does that make sense? Good. Let's see how we can try that in action. To find the volume of this prism, we would multiply the length times the width times the height, right? So 3 times 2 times 7, which is?
42 cubic centimeters.
Good, but this time we would see that our units are meters, so it's 42 cubic meters. Now, imagine we took two of these prisms and glued them together. What would the total volume be?
84.
Good, the total volume would be 84, because if I had one, right, here's one, and I glued a second one to it, the volume of this first one we know is 42 cubic meters, and the volume of the second one is still 42 cubic meters, or centimeters, good. So, the total volume would be 42 plus 42, or 84 cubic meters. Explain to your table group how you know that this volume would be 84 cubic meters. To find the volume of this figure, we'll need to find the volume of this top rectangular prism, and then find the volume of the bottom rectangular prism, and then add it together. However, I want to give you a pro tip. You'll notice that we have some measurements already labeled. We know from here to here is 2 inches, from here to here is 4 inches, from here to here is 5 inches, from here to here is 6 inches, from here to here is 3 inches. But we have a lot of other measurements that are not labeled. For example, I see this line's not labeled, 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 this one's not labeled, this one's not labeled, this one's not labeled, this one's not labeled, and this one's not labeled. Oh, also, this one's not labeled. Do you see that? A pro tip I have for you is to label all the measurements before you do any calculations. This will really save you from making mistakes. They will always give you all the information that you need. However, it may not be super obvious. So let's work together to first fill in some missing measurements. If I know that from here to here is 2 inches, how tall is it from here to here?
2 inches.
Also 2 inches, good. If I know that from here, let me change colors really quick, here to here, here to here is 3 inches, how far is it from here to here?
3 inches.
Good. Okay, so in order to find the volume of this top prism, I'm going to need the length. Do we have it?
Yes.
Good. I'm going to need the width. Do we have it?
Yes.
No, there's nothing on that line. But how much is it? Well, we can look down here and see that it's 5 inches. So this is what I mean by labeling. Label it right there. Okay? And we need the height, 2 inches. So can we find the volume of this top rectangular prism? Yeah, we do it by doing 3 times 5 times 2. What's 3 times 5?
50.
Times 2?
30.
What kind of units do we use?
Cubic inches.
Good. So we know the volume of this top part is 30 cubic inches. Now we need to find the volume of the bottom section. We need the length. Do we have it?
Yeah.
6 inches. We need the width. Do we have it?
Yeah.
5 inches. We need the height. Do we have it?
Yeah.
4 inches. What's 6 times 5?
30.
Okay, times 4 is
120.
120 cubic inches. So we now know that the volume of the bottom part is 120 cubic inches. How do I find the volume of the total? Well, I have to add the top one to the bottom one. So Luke, what 2 volumes do we have to add? In cubic inches.
Plus 30.
Good. Which is? Good. So the total volume is 150 cubic inches.